Live. All right. Okay, it should be going live in just a second. Okay, hello everybody. We are now live. All right. Let's see, Gregorius, you do an audio check real fast? All right. Igor, can you hear him on the YouTube stream? All right, good. Everything's working. Perfect. Happy to see that. Okay, well, I don't know if Andrew or Arjun are going to make it today. I was a little disorganized with getting this meeting put together. I've had a lot of different balls in the air, but we'll go ahead. Oh, there he is. Hi, Andrew. All right, good. Okay, well, we've got quorum here, so we'll go ahead and get going. So this morning, we pushed Akka.NET 1.4.15, which doesn't include a huge number of major changes to, let's say, any of the core libraries. If I go and take a look at the release notes here, if we skip down to the bottom, let's see, we basically added dependency injection support, which is going to be the main thing that we talk about. And then we also fixed a couple issues with Akka.F#. That now supports the newest version of the quotations evaluator. So F# should be able to do things like remote deployments on .NET Core 3.1 now. Gregorius, we added your little with config fallback thing for the bootstrap setup. So that's all included. Otherwise, most of the changes in this release all kind of stem from this Akka.Dependency Injection NuGet package that we just now published. So if I go to NuGet, oh yeah, I'm sharing it on YouTube, but not in Google Chat at the moment. Sorry about that. Yeah, all right, there we go. So I was about to pull up on NuGet, Akka.Dependency Injection. So this is live. It has 0 downloads at the moment. But this is our new DI library, and this one is designed to replace Akka.di.core. So just to give everyone kind of a little backstory, Akka.di.core has been around, oh gosh, let's go ahead and take a look at its history here. Yep, been around since early 2015, so just before Akka.NET 1.0 was released. And it hasn't really changed much since then. It's kind of meant to be a rather simple way of binding a dependency injection container to an actor system. Now, there are a couple problems with it. The biggest one being that Akka.di.core was mutable. You could theoretically change your entire dependency injection system at runtime. In addition to that, it was somewhat deeply ingrained inside the way actors work. We tried to make it so you could inject dependencies through an actor's constructor, and the actor could go ahead and automatically dispose of those whenever it stopped. And that worked reasonably well for some containers, such as AutoFac, for instance, and Castle Windsor worked pretty well, but for others it didn't. Probably the biggest issue with Akka.di.core, though, was that it never really was designed to work with the Microsoft.extensions.dependency injection libraries that have grown in popularity really since ASP.NET Core started getting widely adopted. And that's what that's really what we attempted to fix with the Akka.dependency injection library here. Was we wanted to go ahead and not break backwards compatibility with Akka.di.core, since this is one of the most heavily used Akka.NET NuGet packages out there. So we didn't want to necessarily break the interface for all these. But we did want to go ahead and offer a new path that makes the Microsoft.extensions library a first-class citizen inside the Akka.NET ecosystem. So the thing I wanted to lead with in today's stand-up is actually walking through this code and how it works. Now, one thing I did do right before we released this package this morning is the project site on NuGet for Akka.dependency injection links directly to the updated documentation that we also wrote as part of this release. So we still have all the old documentation for the Akka.di system down here, but this is mostly about how you want to integrate with Microsoft.extensions.dependency injection. So I can go ahead and just read through the documentation here, but that would be boring. So why don't we do a demo instead? So one of the other things we added as part of this release, by the way, an issue that I just closed yesterday, was I added a full-blown ASP.NET Core integration sample as well. And so this sample uses a very minimalist ASP.NET Core code base where we're not using any real Razor pages or any assets or routes or anything like that. We wanted to try to keep the code base as small as possible. So I don't really want to have a bunch of CSS and JavaScript assets floating around inside here. But you still should be able to kind of get the gist of how DI support works. But also, we're going to use this code sample for a future article on how to use Akka.NET inside of the Microsoft.extensions.hosting library as well, which is more or less how we build not just ASP.NET Core applications, but also headless services that run continuously in the background anyway. So for instance, we used to, at one point in time, rely on libraries like Top Shelf to go ahead and build Windows services. Now we can largely express those same ideas through the iHosted service interface and all of the different Microsoft infrastructure that supports that. So if we scroll down here, we have our startup method or startup class, which is pretty standard in any sort of Microsoft application template. And we're going to go ahead and call configure services. This is where we're going to create our DI bindings using the default Microsoft container. So I'm going to go ahead and add a scope service, this little hash service right here. I'm going to add a singleton, which is this public hashing service. This is the service we're going to try to expose inside ASP.NET. And that is going to map to our Akka service, which is where we're going to start our actors and our actor system. And then lo and behold, we're going to take the same Akka service, we're going to go ahead and run it as a hosted service behind the scenes. And what we're going to do is we're going to go ahead and get this iPublic hashing service we bound right here. And we're going to go ahead and use this line to actually start the hosted service behind the scenes. I'll talk a little bit about this pattern in just a second, but long story short, if you ever want to go ahead and create a background service, like in this case, Akkad actors, and you want to expose them through something like a SignalR hub or maybe an ASP.NET or a gRPC interface, this is probably the pattern you want to use. You want to go ahead and take the interface you're going to use to expose your background service, have your service class implement that, register it as a singleton, and then take that same class you just created and go ahead and add it as a hosted service. This will ensure that it actually gets started in the background. This will ensure that you can take that background service and expose it inside your MVC controllers or your SignalR hub or whatever it is you're going to use. So that's what we've done here. So this is pretty simple stuff so far. If we scroll down a bit, you can see my very minimalistic ASP.NET Core implementation, where we're going to go ahead and get this service, the iPublic hashing service here. If I was building a normal, let's say, controller in ASP.NET Core or Razor pages, I would just specify this as a constructor argument. But since I'm using just the Lambda syntax here, I have to go and make this call to resolve that. So we're going to take this iPublic hashing service, we're going to call hashing.hash on it, and we're going to pass in some input along with a cancellation token. And we're going to get some output back, this little hash reply object right here. And we're going to write out to the response stream that this actor, this hash.hasher, hash the trace identifier into this. And we're just going to use the little murmur hash inside Akka.NET. Well, let's actually take a look at what our Akka service, or what our public hashing service does. All right, so it's pretty straightforward. We have this little task we're going to return that has a hash reply. We're going to take a string as the input and a cancellation token. This is going to be the service that we exposed to ASP.NET Core. We just saw that a minute ago. And this is the service that we're actually going to inject inside our Akkad actors. We're going to have this little hash service right here, and the underlying implementation is going to go ahead and use murmur hash. And I made this disposable just to go ahead and, I don't know, if you want to do a little demo that shows, the actors' dependencies being disposed properly, this will all show up. But the real meat of the application is our Akka service, which implements the public hashing service interface along with the iHosted service interface, which is what we need to run this in the background. So this service is going to take a reference to the iService provider. This is the sort of factory interface for being able to work with the dependency injection system in ASP.NET, or really any Microsoft.extensions.hosting service is going to expose this. So we're going to go ahead and save a reference to this. And then down below, in my start async method to start my iHosted service, this is part of this interface up here, I'm going to go ahead and await a little call to read my HOCON configuration, which is pretty simple. We're just going to declare a little random pool router underneath the surface. So we're going to go and read that. We're going to create a bootstrap setup that's going to read in that HOCON file here. And then this is the brand new Akka.dependency injection library at work. This service provider setup is a type that's defined inside the Akka.dependency injection library. And this gives us a programmatic way of passing the service provider that we grabbed up here, passing that into our actor system so we can use all the registrations that are bound to that DI container to help instantiate actors. So we're going to go ahead and take these two setup classes and merge them together by calling the setup.and property. And this gives us a type called an actor system setup, which the actor system.create method will take as an argument. So this will go ahead and give us our actor system. And then down below here, I'm going to go ahead and call this extension method serviceprovider.for, and I'm going to pass in a reference to my actor system. This will allow me to retrieve the iService provider that was bound to this actor system anytime I have a reference to it. So if I'm inside an actor, I can always get a reference to my actor system. Or if I'm defining code at my startup of my actor system here, it's very easy for me to do that. I'm going to say serviceprovider.for props hasher actor. So this will go ahead and create a brand new set of props that are going to use the service provider to populate the constructor arguments that my hasher actor expects. Now, right now, the only constructor argument we're taking is the service provider. This is because we're kind of following along with the Microsoft best practices for dependency injection, which are that if you're creating objects that are going to be in anything other than a transient scope, you should go ahead and always pass in the service provider as a little factory method, and you should create and manage your own scope and then dispose of it when you're done, which is exactly what we're doing here. We create a scope inside our constructor. We use the scope to go ahead and create a required service that we're going to use, this iHash service. And then in our post-stop method, which by the way will also be called whenever this actor gets restarted in the event that it crashes, we're going to go ahead and dispose that scope, and that'll dispose of any of the resources we bound to that dependency injection container, either as a transient service or as a scope service. They'll all get disposed. Otherwise, every time this actor receives a little string here, we're going to go ahead and call the hash service on it, and then we're going to send the sender a little hash reply. So go back to my Akka service. We're going to go ahead, create this little set of props here using the service provider extension that's included inside the Akka.dependency injection library. We're going to call actor of, and I'm going to say hasher props with router from config.instance. That's going to turn this single hasher actor into that random pool. And so down below here, I'm going to implement the iPublic hash service interface, and we're just going to go ahead and use the ask pattern to go ahead and query this router actor and try to get a reply back that we can go ahead and expose in our HTTP route. So I'm going to run this real quick, just to kind of show you how it works in action here. I've got one more little piece of code I kind of want to bring up once I've got this up and running. Okay, so you can see Akka ASP.NET demo /user/hasher, and then this is one of the randomly named children in that random pool. Hash this trace identifier into this 32-bit integer. All right, so if I reload this, you'll see that it's a different actor, a different trace identifier, and a different hash each and every time. So this is just kind of showing you that all these different actors were all created via dependency injection under the covers, and are able to go ahead and use the service provider to resolve these little hashing components that they need in order to do their work. And it's all working pretty smoothly. Now, the part that I really appreciate about the Akka.dependency injection library is that it also solves a really long-standing complaint that users have had about how DI works in Akka.NET for a long time, which is I either have to let the dependency injection system handle everything, or I have to let it handle nothing. There's no in between. What if I want to be able to inject some arguments via dependency injection, but not others? How can I solve that? And we haven't had a good answer on that for the better part of 6 years. Now we finally have one, and I'll go ahead and show you how that works. I'm going to go up to the Akka contrib dependency injection folder, and we're going to take a look at the unit tests for this library. So if I scroll down here, we have a number of different little scenarios that we're testing based on different blends of DI'd arguments, different scopes for those arguments, and so forth. But the one I really want to show, and I actually referenced this in our documentation, is down here. We have this non-DI args actor. And this actor takes, in terms of its dependencies, it takes a singleton, it takes a service scope, and within that scope, we're going to take a transient and a scope dependency. But then we also take these two string arguments right here. And if you look at the constructor of this actor, we're going to pass in the singleton dependency. We're going to pass in a reference of the service provider because we need that in order to create a new scope for us. And then we're also going to pass in these string arguments. Well, if I go and I scroll up, actually, let me take a look at this first. This is the DI fixture we use for creating the little DI container that we're going to use for running all these tests. Well, if we take a look at it, if I scroll down, we're going to create a service collection. We go ahead and add a singleton. We add a scope dependency, and then a transient dependency. And we go ahead and we build a little service provider once we're done doing all of that. Well, as you might notice, one thing we are not doing is we're not binding any strings, and we're also not binding the actor types to our DI containers at all. When I go to my unit test where this gets referenced, I believe that's right here. So we already have our actor system because we're using the Akka.NET test kit for this. So that's already up and running. We're going to go ahead and call service provider.for, grab a hold of the service provider for this actor system, and we're going to do the following. Service provider.props, we're going to pass in the actor type, and then we pass in the arguments that are not supplied via dependency injection. And after we do this, we can go ahead and start the actor, and we can verify that it all works. And we can also go ahead and verify that the non-dependency injected arguments were passed to the actor's constructor correctly. So if I go and run this test real quick, hopefully this won't take too long, because I don't know if I actually have cached the most recent Akka.NET build symbols in this machine. Looks like it's going to run good. If we go ahead and rerun this, perfect. Those actors who receive non-DI dependencies should be started correctly. And I was also able to verify that all this works when we restart the actors as well. So that solves a long-standing sort of complaint that users have had about DI and Akka.NET for a very long time. So at the moment, our DI system is extremely simple for DI now. It's meant to kind of support all these different combinations of use cases that developers might have. But the one thing we explicitly decided not to do with Akka.NET dependency injection is we decided no magic. Akka.NET is not going to try to manage the lifespan of any of these dependencies for you. We're not going to try to guess when they're going in and out of scopes or if they're transient. We're not going to try to automatically dispose of those for you when the actor shuts down. That's your responsibility. And we document this pretty clearly in this section of the Akka.NET dependency injection guidelines. Managing lifecycle dependencies with Akka.NET dependency injection. We walk through this, we have some code samples, and we have a set of best practices down here for how you should use it. And this is all, by the way, an extension of Microsoft's dependency injection guidelines. So all of that's available, starting with Akka.NET 1.4.15. We would love some feedback on it. If there are things we can do better with it, please go ahead and open a discussion on GitHub or open an issue. We wanted to start with something that was really simple at first. If it turns out maybe there is a way we can automatically manage stuff, maybe we might be open to it, or maybe we might decide it's too complicated and you're better off just calling an extra line of code to create your own scope and dispose of it that way. But that being said, this is all available now. It's probably the biggest thing that we're including in this release. We hope you like it. Please give us some feedback on it. Now, for the contributors who are on the call with me, do you guys have any questions about how this stuff works? Any feedback on it? Anything we need to consider for the next release? Yeah. Yeah, Gregorius, you were asking for a copy of this yesterday, right? Good. And what was remind me again, what was your use case for it? It was working with the Event Hub stuff we were doing, right? Ah, gotcha. Good. Good. Well, so it looks like we're going to be dog fooding it ourselves in short order here. Andrew, do you have any feedback on this? No worries. Well, good. Well, right. Well, that was kind of the first big thing that I wanted to cover, was talking about DI support and our Microsoft.extensions.hosting example. One of the things I'm going to be doing after this call today is I'm actually going to be doing a little YouTube videos that are going to cover more or less what we just did. But I'm going to try to be a little bit more prescriptive about it and have some documentation that says, here's how to use Akka.net inside, an iHosted service and all that stuff we just went over. So I'm going to try to put some more prescriptive content about that up on the YouTube channel in just a little bit. But that's the 1.4.15 release. Next, I want to go ahead and talk about a project that I've been bringing up for going on 2 or 3 months now. And yeah, go ahead. Mm-hmm. Yeah, it is. So you're absolutely right. That explicit step of registering it as a singleton first is absolutely necessary. So that's something that we definitely need to reiterate. Otherwise, you might end up with multiple actor systems. Oh boy. Okay, well, good. We've got a whole bunch of people watching today. Hi from the Netherlands, Belgium, Sweden. All right. Christoph Lawyers is saying we can't hear the other people talking. Did I screw that up again? Yeah, I thought we did. Is it supposed to be capturing anything that's on my output microphone this time around? Well, crap. I even set up a checklist for doing this, and apparently I executed it wrong. So I might need to go ahead and give that another try again. Well, no worries, guys. I'm going to probably do 90% of the talking here for a couple minutes. So that should be all right, I guess. Next thing I want to talk about was our community standards updates. So if I go and pull up I think this is a project on the Akka.net repository. Yeah, here we go. So one of the things I'm working on, I've talked about this before, is this is all designed to do a couple of things. One is make it easier for people who are not, let's say, core developers who work on Akka.net all the time, make it easier for them to contribute to the project. And I took our first step towards really implementing some of this stuff this week, which is this is a special type of GitHub repository that you can implement in your organizations. It's called the .github repository. And what's going to happen is standard bits of content, such as I took the .NET Foundation Code of Conduct, which right now you can only find in You can only find that in the main Akka.NET repository, but that code of conduct is really meant to kind of govern how the organization does stuff inside our project. So I was able to go ahead and add a reference to it here, and this code of conduct will be implicitly copied into all the different repositories. Now, there's a bunch of different pieces of content that are going to go into this repository. Code of conduct was just this kind of easiest way for me to test that this actually works. The next things that we're going to move into there, if I go and pull this up real quickly, next things we're going to go and put into there are, well, I guess it doesn't say on this issue, but it's going to go ahead and include things like a support file that basically explains to Akka.NET users where to go to get their questions answered. So that'll include links to the Github chat room. It'll include links to our, the Stack Overflow tag for Akka.NET. It'll include links to the discussions area in this repo. It'll also include a link to things like Petabridge's paid support plans and stuff like that. These are just sort of instructions on how to get help if you're working with the project. We'll also include things like our GitHub issue templates will all go in there. That way, those same templates can be applied to every single repository. So I won't need to, let's say, set up one set of templates for Akka.NET and another set of templates for Akka.Persistence.SQL, and I won't need to set up another set of templates for Hyperion. Rather, we'll have one set that kind of covers all of them, all being derived from this one repository here. So that's one thing that we're going to work on, and I was planning on getting a little bit more work done on that today, but I ended up writing all this DI documentation instead, which is probably a better use of time today, to be honest. But that's one thing that I'm still working on. So we've got the infrastructure in place to do some of this now. Now it's just a matter of doing it. Now let's see. The next thing I wanted to go ahead and cover real briefly is Akka.Persistence.LinkToDB. Now, Andrew, before I ask you to go ahead and cover this, I'm going to try one last time to go ahead and add another audio source to our application here. So I'm going to go ahead and add desktop volume. Let's see. Hey, Gregorius, can you do an audio check for me one more time? You know what? I figured out what the problem was. I set everything up correctly, but OBS, or whatever it's called, OBS, is listening to the wrong device. So, yep. Okay. Let's try that again real quick. Properties. Yeah, it looks like it should be right. Let me just check my settings right here. And let me go ahead and check my settings here real quick. We'll eventually get better at this. I figured it out. That's what's wrong. Okay. One more time for me, Gregorius.
Righto. Mic check. 1, 2, 3. Test.
There we go.
Mic check.
I think I'm seeing it. Yes, I'm seeing it show up now. Damn it. It was that my everything was set up correctly except for Google's Google Meet was not set up correctly. Okay, good. Well, this puts us in a better position to cover the next part. So, Andrew, would you mind talking a little bit about Akka.Persistence.LinkToDB real quick? And what I'd like us to go over is what it is, how it's different from traditional Akka.Persistence, and how the release cadence for it is going to be, how it's different from Akka.Persistence.SQL in particular, and how the release cadence for it is going to be a little bit different going over time. So let me go ahead and pull up the source real fast. All right, go ahead.
All right, so Akka Persistence LinkToDB is actually a inspired port of Akka Persistence JDBC. Basically, as we were working at my work environment, dealing with a larger Akka cluster, using sharding and persistence and requiring a lot of fast writes, we were just noticing some room for improvement. Looking into the Akka Persistence JDBC provider, they have a very unique way of batching and streaming that batch data to the database, utilizing Akka streams. It allows for very, very large horizontal scalability. Aaron, if you would be kind enough to scroll down in the README to the benchmarks portion.
Yes, you got it. Here you go.
So basically what winds up happening is as writes are pending, they get added to a queue. as opposed to the idea of the existing batching journal, which kind of tries to roll the commands up and then executes them all in a transaction. This still gets you the atomic writes that are required by Akka Persistence. However, it is able to stream that more efficiently using Akka streams. Link to DB has bulk insert capability that is very, very powerful. We can kind of see here actually as we scale up from just one actor persisting, which is a little bit slower than the batching at that stage. However, in most real world scenarios, you're not going to have one actor going. You're going to have quite a few. And we can see here in that case, as we scale up to 10 actors, we're almost twice as fast as the normal journal, about 50% faster than the batching. But as we scale up to 100 or 200 actors, we are seeing it almost an order of magnitude difference with the normal journal and a 500% difference on the batching. And this also helps a lot with write contention because based on the way it's configured, you only have the default configuration is a node will have only 2 writers going at the table at a given time, which in most databases, especially SQL Server, that's better because of the locking model. That is tunable via configuration. We've made a point to put in backwards compatibility here, so that if you want to move away from the existing journals, I would suggest making sure to do all of your proper validations at this stage if you do try to go down that route. But basically, it is able to read the existing journal table structure, including the journal metadata concept, and issue its updates and deletes in a way that is compatible enough that if you want to try it in your beta environment, and if you decide to change your mind and flip it back, it should still all just work. And there's unit tests around that compatibility as well. So what we're trying to do as far as a release cadence on this is currently there are compatibility tests and configurations for SQL Server, SQLite, and Postgres, except for JSON mode. There's no support for the JSON column store at this time. But there are no unit tests around MySQL, Oracle, or the other providers that Link to DB supports. That is actually another huge advantage of going down this route, is Link to DB is a very provider agnostic framework. And what that lets us do is technically there's nothing stopping you from trying to wire this up to Access. I would not suggest doing so, but theoretically you could. But what we would like to do is earlier on, we would really appreciate the community's help in getting those other tests fleshed out as far as MySQL, Oracle. I know there's some Oracle members out there in the community. Giving it a few tests around things like the persistence queries. There are some optimization opportunities there. But basically, we would like to do some more frequent releases on this until it's stabilized and eventually align it closer to the standard release cadence.
Thanks. That's a great summary. So the performance numbers, particularly on write workloads, are significantly higher on Link to DB, and that benefit grows the larger, let's say, the larger number of concurrent writers you have. So we know we have some users of Akka.net that are using things like large numbers of persistent actors via Akka.cluster sharding. This is a plugin you're going to want to take a look at. So Andrew and I were just discussing in chat a little bit earlier today about getting the first version of this up on NuGet as soon as we can. So we'll probably be typing up some release notes. I'm going to have to add a release pipeline for this in Azure DevOps, which should take about all of 2 seconds to do. So we'll go ahead and get all that set up, and we'll try to get a version of this up and running on NuGet as soon as we can. And we would really appreciate the community's help in helping us find maybe areas where we can improve the performance of certain things, or also we want to know about compatibility issues issues with migration paths and that sort of thing. So we would very much appreciate you taking this for a test drive and letting us know how well it works for you. Because if the performance numbers hold up here over, let's say, several different releases of the software, we might start nudging users towards this as the default set of Akka Persistence plugins for relational databases they want to look at. But of course, that requires actually being deployed into real applications and being successful there. But we're very confident that this will work well. Okay, let me just take a look in chat for questions. Kevin Blockland was asking about, I'm going to bring my microphone with me here while I look. With the DI string args, is this typed? The answer is, Kevin, in terms of how we do a mixed dependency injection with actors using that, it's all being done. If I go and take a look at the Akka.NET source code real briefly, it's all being done through a class that is built directly into Microsoft.extensions.dependency injection. And so if I go to service provider, I believe it is in this class down here. It is this class that's doing all the magic. The activator utilities, .create instance, actor, and we pass in the service provider and all of the arguments. So this class, which is built by Microsoft, is performing some type of reflection magic behind the scenes. I don't know what it is, and the beauty of this design is that I don't have to. Microsoft will auto-magically figure it out for me, and in the event that they don't, we can file a bug on their repository. So that's the gist of sort of how that magic works behind the scenes, is that I don't know, and I'm glad I don't need to. But it looks like to me, the way this works, like if I take a look at my example I brought up earlier, this non-DI args actor, it looks like the way this works is it's going to go ahead and match the arguments positionally, where it's not going to look at the name of the value being passed in versus the name up there. It's going to say the first string goes in the first string argument, the second string goes in the second string argument. That kind of appears to be the way it's going to be done inside the activator utilities class. All right. Now for the next thing that we're going to be taking a look at here is getting ready to start attacking Akka.NET 1.5 a little bit more aggressively. What's needed to be done there is we have a couple of ongoing projects that are all part of that milestone. Artery, porting some various components to Akka streams, in particular updating the materializer. There's some dispatcher changes that we discussed. And then finally, there's bringing back standalone Hokon again. So one of the things that I'm going to try to have done within the next month is having a public milestone that breaks these down into fungible issues that individual users who are not members of the core development team could actually feasibly go ahead and commit some of these if they want to. So if you're interested in, let's say, having a hand in maybe working on some of the updates to Hokon, or if you want to work on the guts of Akka streams, or if you want to go ahead and work on something like the dispatching system, which is going to be built around value task and all that sort of stuff going forward, we'll have some opportunities to go ahead and do that. So this is a project that I said within a month. Realistically, this is probably more like 2 months probably, because this requires breaking some stuff down to a fairly small level of detail. But this is something that we're going to begin starting on. The Akka.NET 1.4 sort of life cycle is kind of, I think we've kind of reached a point where a lot of the major changes we want to start introducing are big enough that they should probably be moved into a new minor version of Akka.NET. So that'll be something that's coming up. And you should expect to see some updates from us coming soon. These community standards updates that we're working on will help you, if you want to contribute, will help you kind of wrap your arms around what's the process for doing this. How do I make sure my pull request is going to be merged in successfully? And what are some things I need to do in order to help achieve that? So we're going to go ahead and walk through some of that as part of our community standards updates, which isn't just about GitHub templates or that sort of thing. It's also going to provide some guidelines for understanding sort of what gets merged and what doesn't. So the next thing I want to go ahead and talk a little bit about is a couple of updates coming to the other sort of community-driven updates. One thing I should bring up, and I really should have had a hyperlink to this. If I go ahead and grab a tweet from Petabridge real fast, grab this, here we go. Let me go ahead and pull this up in its own tab here. All right. There we go. One thing we're going to be doing, I went ahead and I blasted this out on Twitter yesterday. We're going to be doing a free webinar that's all about learning how to do Akka.NET monitoring, tracing, and alerting. So we're going to be talking about things like structured logging with serial log and seek, how to set up alerts for that, what sorts of metrics you want to pay attention to. We're going to talk a bit about tracing Akka.NET as well. A lot of this is going to feature Phobos, which is a paid add-on for Akka.NET that Petabridge develops. But a lot of the things we're going to cover, in particular the types of metrics you want to look at, are things you could easily instrument yourselves if you are not a Phobos subscriber. So there'll still be some value in that if you're not a Phobos user. You can go ahead and get the link to join this from Petabridge's Twitter feed here. The next thing I want to talk about real briefly is the Petabridge.command streaming protocol. So Petabridge.command has been a popular tool for a few years now for managing, in particular, Akka.cluster applications. It's not open source, but it is free to use, and it's highly extensible. You can write your own custom commands for it if you want. One of the things that we're going to be adding to it imminently, I've actually got some designs to start working on this sooner rather than later, is we're going to add the ability to strongly type all of the commands so you can actually build applications on top of it, not just have to use it through the CLI. So for instance, we have a number of commands that are designed to stream logs, to stream events about the cluster, and some other commands for transmitting data about things like the distribution of shards inside the cluster sharding system. You're going to be able to consume the event format for all of those through the libraries that define those commands and interact with Petabridge.command programmatically. This will make it easier to start doing things like building more monitoring solutions on top of Petabridge.command, which is what we're going to use it for, being able to do things like programmatically, let's say, administer application-specific changes to your system. So a good example, in the event that we're using, let's say, Azure Event Hubs for a part of Petabridge's systems that we're building on top of Akka.NET. If we want to go ahead and issue a command that'll, cause us to go ahead and do a scan through one of the Event Hub partitions, that might, just for diagnostic purposes, that's something that we might be able to implement on top of Petabridge.command real easy. So it kind of gives you the ability to query a live production system. So this is kind of meant to extend Petabridge.command beyond just being, let's say, a command line interface to actually being an application programming interface if you want. So that's going to be shipping out as probably part of Petabridge.command 1.0. That will still target Akka.NET 1.4, so we're not going to need to wait for the 1.5 release to do that. And I basically have all the designs on paper for doing this. I just need let's say, a couple of free weekends to go and implement it. So that's something that's going to be coming up soon. The last thing I wanted to mention is I've been involved with the .NET Foundation's Grow the .NET Ecosystem Council, whatever the hell it's called. Maybe it's a committee. I don't remember anymore. I'm not much of a titles guy. But one of the ideas I wanted to steal from them was I would very much like to go ahead and build up a couple of areas in the community section of the Akka.NET website where we can make it easy for people who are using Akka.NET to go ahead and advertise their company and talk about the use case here, get a link back to their business if they want to, or if you want to include a link where maybe you're hiring people for your engineering team, you could certainly do that. That's something that we're going to add support for. The other thing what we're going to do is go ahead and add a link for, let's say, third-party projects that are built on top of Akka.NET. So a good example, there's the very popular Akkaling library built by Bartosz, which is a popular F# API. There's also Architecture, which is a very popular CQRS and event sourcing framework built on top of Akka.NET. But there's also some really fun stuff like the Neo cryptocurrency, which is fairly similar to Ethereum in terms of how it works. I think it implements smart contracts and some of that other stuff. That's also built on top of Akka.NET Actors, in case you didn't know that. We also want to give people an area to go ahead and link to blog posts, YouTube videos, Pluralsight courses, all that good stuff. We kind of want to make it easier to sort of surface what people are doing inside the community with Akka.NET, make it so they can go ahead and get some traffic maybe from the Akka.NET website, but also give people who are trying to find answers to their questions more places they can go look. So that's something that we're going to be working on too. That shouldn't take very much time to go ahead and do that. We already have one area on the website. I think production use case and users for Akka.net right here. We have not really updated this in, gosh, I don't know, 5 years. So we do have an area in here where we do talk about Akka.net uses and use cases. We're going to go ahead and revisit this and try to make it a little bit more interactive. So we're going to add some guidelines on how to add your company to this. We'll probably add some GitHub templates for doing that. And that should be a new initiative that I think will help kind of expose how big the Akka.net community is and really help make it easier for people who want to write blog posts or make YouTube videos or promote Pluralsight courses, get some interested users in front of them that way. So that's what I've got for this month's community update. Gregorius, Igor, and Andrew, or Arjun. I know Arjun, you're just streaming via YouTube. Do any of you have anything you want to add, or is there any questions from anybody in the community?
I don't think so.
Yeah, I don't think so too.
Nope.
Good.
All right. Well, thank you very much, everybody. I really appreciate it. Let me see if I can go and drop a link to the little webinar registration page here. I guess I can do that in chat. There we go. We'll see if that goes through. Honestly, I'd be a little surprised if YouTube allowed it. But thank you very much for your time this week, everybody. I really appreciate all the participation. If you have any questions about anything that we're going to be covering, or if you want to get involved with the Akka.net project, you can always go ahead, go over to Akka.net and click on, if I scroll down here, you can always go ahead and go to the discussions area, or you can go in the Gitter chat, or you can reach out to us on Twitter. We're pretty easy to get a hold of. But otherwise, thank you very much for your time this month, everybody. Really appreciate it. We will see you in February.